following expressions completely. That means exhaust all methods of factorization. See if we can find an example like that. So our first one just says a minus b all squared minus 3 multiplied by b minus a. So first things first, well, a minus b and b minus a are almost the same. However, if I want to create a factor, and a common factor at that, first thing I need to do is make sure that I take out a negative 1 as a factor over there. So let's leave this alone, maybe expand it, and then because I'm taking out the negative, a negative and a negative will become a positive, and now I can do a switch around. So there I have my common factor, which is a minus b, and then what's left is a minus b plus 3. From that I can see there's nothing left to do. Second example, you can do that in orange. Well, 1 over 27 x cubed plus 216. Well, I can see that this is my clue. Well, x cubed is a perfect cube. 27 is a cube, and then 1 is one of those weird ones. Well, 1 to the power of anything is 1, so 1 cubed is still 1, hence I have a cube. And this cube root of 216, last time I checked, should be 6. Well, that is just going to be 1 over 3, which is the cube root of 1 over 27. And then x, cube root of 216, should be 6. So, square this. That's going to be 1 over 9 x squared. And then at the back end, we'll have the square of 6, which is 36. Positive, of course. And then for the middle term, we know we should change the sign. A third times 6 gives us 2, and it's just x. And that is an example of sum of 2 cubes. Let's create some space at the top. Should be done with that by now, obviously. Okay, let's pick a new color. Yellow or blue with a pen. So now we have m cubed minus m squared minus m n squared plus n squared. Well, let's see, try a grouping over here. There and there, because we have 4 terms. Well, for the first grouping we have m squared we're going to take out, and then it's just m minus 1 that's left. Well, and in the second grouping, let's take out a negative n squared, and what will be left with? A m, because the negative times the m is going to give us that back, and then we'll have minus 1. I think I made a little mistake here. That should be m, because this was m. Well, now we have a common factor of m minus 1, and then we have m squared minus n squared being left, coming from there, of course, and there. And now the word completely comes into play, because there we have the difference of 2 perfect squares. So let's bring out m minus 1 factor, and then obviously the difference of squares is just a copy of the factors with a difference in sign. Now that should be that. Could have made that arrow better.